Hello, everyone. I'm not even going to introduce myself for this problem because it's so long and complicated. So let's just jump right into it. You are shooting an arrow at a 35-degree angle at 80 meters per second from a height of 400 meters. The first thing you need to find is the peak. What is the maximum height that this arrow reaches? So with these kinds of problems, you always want to start off by writing down your knowns and unknowns. So I know the initial velocity is 80 meters per second. I know my angle is 35 degrees. My y initial is 400 meters. The y final changes throughout. The time that it takes to reach the peak, t sub p, I don't know. And that's what I want to find out. Or, well, the height, sorry, at the peak. And then I know that the acceleration in the y direction is negative 9.8 meters per second. The initial velocity in the x direction is 80 cosine 35 and 80 sine 35 in the y direction. So to start off, I need to use an equation to find out what my height is. I'm going to start off by using this equation right here. So let me just share my screen really quickly. So I'm going to start off by using this equation right here. A average equals V over delta V over delta T. So with that equation, I know that and I'm going to use it in the y direction. So I know that my acceleration in the y direction is negative 9.8. The final velocity will be 0 at the peak. I won't have any velocity in the y direction at the peak. And my initial y velocity was this, so I need to find time. After rearranging the variables, I find that my time is 4.68 seconds. That's how long it takes to reach the peak. So now I'm going to use a different equation, and I will share that right now to find the height. So now I'm going to go ahead and use this equation, V average equals delta x over delta t, to find the final height. So I start off, here's my initial velocity, my final velocity is 0 over 2. This is my average velocity, Vi plus Vf over 2, equals y final minus 400, that's the initial height, times divided by 4.68. So then, after plugging in all those numbers, I get that my final height is 507.37 meters. And if we do a sanity check, it does indeed sound right because we need our height to be higher than 400 meters. So that sounds good. The next problem is to find out what the height is if you shoot this arrow at 30 degrees. Now, the problem states below the horizontal, what the degrees are below the horizontal. If that's the case, then the peak height is only going to be 400 if you shoot this 30 degrees below the horizontal, because obviously it can't go up if you shoot below the horizontal or you shoot down. But I assume that this problem is asking what the peak height is when you are shooting at 30 degrees. So you do the exact same thing, except I'm basically replacing everywhere where I see a 35 in the previous problem with a 30. So after I do all that, I get that my final height is 493.6 meters. And that makes sense because in the previous problem, I got 507 meters. And this is a little less because we tilted our angle down more. So that makes total sense. Excuse the phone. So now let's go on to the next problem. We are trying to find out what the velocity is after 9 seconds. So we start off with, we have to know these equations. We have to know v of x squared plus v of y squared equals v squared. So that's the first thing. And then the next thing we have to know is that v sub x equals v cosine theta and v sub y equals v sine theta. So I'm going to use that equation we used previously, A average equals delta V over delta T. And now my new delta T is 9. I want to know what the final velocity is at 9 seconds in the y direction and in the x direction so that I could plug these two into here and find my final velocity. So after plugging in those numbers, I get that the final velocity is 44.79 meters per second in the y direction, and the final velocity in the x direction is 65.53 meters per second. So I plug these two into this top equation here, and I get 79.1 meters per second. But I'm not done yet. I have to find the angle as well. So to find the angle, I'm going to take either one of these equations here and solve for theta. So I decided to take the y direction equation. So I know that Vy is 44.79 meters per second. V is 79.1 sine theta. So I solve for theta by taking the inverse sine, and I get 34.1 degrees. So then the next problem asks me to find out what the velocity is right before it falls down and hits the ground. So I am going to use this equation, delta y equals v initial y times t plus 1/2 ay times t squared. And I want to find out the total time that this arrow is in the air. So I know the time that it took for it to reach the peak. So I'm going to start from the peak to when it lands and find out how much time it takes to get from there to there. So what that means is I know my initial y is going to be 507.37 meters, and then there's a negative sign there making this negative. I know that my initial y velocity is 0, so this goes to 0. I know my acceleration in the y direction, and I'm looking for t. So after plugging in all of that stuff, t is 10.17 seconds. So now I'm going to do a similar thing I did last time. I'm going to find out what the velocity is in the x direction and y direction. Okay, and I'm going to again use the acceleration average equals delta v over delta t. So I find in the y direction that my velocity final is negative 99 meters per second, and for x it's 65.5 meters per second. It makes sense that this is negative 99. That means that the direction is negative, and I expect the arrow to take on a negative trajectory toward the end of its flight in the y direction. So to find out v, I go ahead and plug in the terms for vx and vy, and I get 119.24 meters per second. So then, similar to the last problem, I'm going to find out what the angle is right before it hits the ground. And I picked the x direction this time. So v of x equals, let me just go ahead and show you the equation real quick. Not there. So I used this equation right here, v of x equals v cosine theta. So I know my v of x is 65.5. I know my velocity, and I know theta. So, well, I don't know theta. I need to find what that is. So again, cosine inverse of 65.5 over 119.24 equals theta. And theta equals 56.7 degrees below the horizontal. This is below the horizontal. And that's another can of worms as to why this is below the horizontal and not above. It has to do with the domain of cosine. If you did this for the y direction and had Vy equals v sine theta and solved for theta, then you would get a negative 56.7. That's verifying this answer right here. And then the last part of the problem, which I actually forgot to do, but we could work it out right here. So what is the error at the moment there? It takes 0.025 seconds for the arrow to come to a complete stop when it hits the ground. What is the acceleration of the arrow? So I can use the equation A average equals delta V over delta T. So if I use A average equals delta V over delta T, I know what my delta V is and I know what my delta T is, so I could easily find A average. So I'm going to go ahead, and for my delta V, I found out that it was 119.24 meters per second. So that's going to be V final minus V initial over delta T. And I know my delta T is 0.025 seconds because it's given in the problem. So A average, I keep messing that up. A average is equal to, so my v final is 0 because it comes to a complete stop, equals 119.24 meters per second over 0.025. So then my acceleration average, if I plug this into a calculator, is going to be, let's see, 119.24 divided by 0.025. That's negative 4,769.6 meters per second squared. And that makes sense because this thing is slowing down. It's decelerating into the ground. So that was a lot. If you have any questions, please leave a comment or reach out to me personally. Thank you.